Type MC cable is required to be derated when bundled, regardless of the length of the bundle. There are several reasons for this requirement. Firstly, reduced heat dissipation occurs. When the MC cables are bundled, heat dissipation from the individual cables is reduced due to the close proximity of the cables and the outer jackets. This can lead to overheating and premature failure. Secondly, increased current concentration happens. When MC cables are bundled, the current flowing through the individual cables can become concentrated in certain areas of the bundle, also leading to overheating and damage. The National Electrical Code (NEC) requires specific derating factors to be applied to Type MC cable when it is bundled. For 3 current-carrying conductors, derate by 25%. For 4 current-carrying conductors, derate by 30%. For 5 or more current-carrying conductors, derate by 40%. Here's an example. If you have a bundle of 3 Type MC cables, each carrying 30 amps, the maximum allowable ampacity for the bundled cables would be 30 amps multiplied by 0.75, which is the 25% derating, equaling 22.5 amps. While Type MC cable has similarities to flexible conduit, for example a metal outer sheath, it is not considered equivalent for the purposes of derating. This is because the conductors in MC cable are in direct contact with the outer sheath, while in flexible conduit the conductors are separated by air or insulation. Therefore, it is necessary to derate Type MC cable when it is bundled, even for short distances. This ensures proper heat dissipation and prevents overheating or damage to the cables. The derating requirements for bundled MC cable exist to mitigate the risk of overheating, which can lead to insulation breakdown, short circuits, and potentially fires. By reducing the allowable ampacity of the conductors within the bundled cables, the heat generated is kept within safe limits. To accurately determine the allowable ampacity of MC cables in a bundle, follow these steps. Firstly, determine the number of current-carrying conductors within the bundle. Remember to count all phase conductors and the neutral conductor if it carries significant current, such as in a 3-phase system with nonlinear loads. Secondly, identify the appropriate derating factor from the NEC table based on the number of current-carrying conductors. For example, if you have 5 current-carrying conductors, the derating factor would be 40% or 0.60. Thirdly, find the initial ampacity of the MC cable from NEC table 310.15b16 of the cable's marking. This ampacity is based on the conductor size and insulation type. Fourthly, multiply the initial ampacity by the derating factor to obtain the adjusted ampacity. This is the maximum current the conductors in the bundled MC cable can carry. The NEC provides tables such as 310.15b16 that list the allowable ampacities of conductors based on their size, insulation type, and installation conditions. These tables assume that the conductors are installed in a way that allows for adequate heat dissipation. When cables are bundled, this assumption is no longer valid and derating is required. Some common mistakes to avoid are firstly forgetting to count the neutral conductor as a current-carrying conductor when it carries significant current. This can occur in 3-phase systems with nonlinear loads, such as those with electronic equipment. Secondly, using the wrong derating factor. Always refer to the NEC table for the correct derating factor based on the number of current-carrying conductors. Thirdly, neglecting to consider the ambient temperature. The ampacity values in the NEC tables are based on a specific ambient temperature. If the ambient temperature is higher, the allowable ampacity must be further reduced. Fourthly, failing to properly support the bundled cables. Bundled cables should be supported in a way that allows for air circulation and prevents excessive heat buildup. Different types of MC cable have different construction and insulation properties, which can affect their heat dissipation characteristics. While the NEC derating requirements apply to all types of MC cable, some types may be better suited for bundling than others. For example, MC cables with a larger outer diameter or a more thermally conductive jacket may be able to dissipate heat more effectively. Always consult the cable manufacturer's specifications for guidance on bundling and derating. Consider these factors when choosing MC cable for applications where bundling is necessary. Firstly, choose cables with a larger conductor size than required by the load. This will provide a greater margin of safety and reduce the amount of heat generated. Secondly, use cables with a higher temperature rating. This will allow the cables to operate at high temperatures without degradation. Thirdly, select cables with a more thermally conductive jacket. This will help to dissipate heat more effectively. Fourthly, consider using cables with a built-in grounding conductor. This can simplify the grounding of equipment and reduce the risk of electrical shock. In some situations, it may be possible to avoid derating MC cables by using spacing or other methods to improve heat dissipation. For example, cables can be spaced apart using cable ties or other supports. They can also be installed in a ventilated area to allow for better air circulation. The NEC does not provide specific guidance on spacing requirements, but it is important to ensure that the cables are adequately cooled. Regularly inspect bundled NC cables for signs of overheating, such as discoloration, melting, or deformation. If any signs of overheating are detected, take immediate action to reduce the load on the cables or improve heat dissipation. The NEC is updated regularly to reflect changes in technology and industry best practices. It is important to stay up to date on the latest requirements for derating MC cables and other electrical installations. Regularly consult the NEC and other relevant standards to ensure compliance. In addition to the NEC, there may be other local codes or regulations that apply to the installation of MC cables. Be sure to check with the local authorities to determine the applicable requirements. Proper planning and installation are essential for ensuring the safe and reliable operation of electrical systems. When working with MC cables, always follow the manufacturer's instructions and the requirements of the NEC. The ampacity of a conductor is the maximum amount of electrical current it can carry continuously without exceeding its temperature rating. This rating is determined by the conductor size, insulation type, and installation conditions. Exceeding the ampacity of a conductor can lead to overheating, insulation breakdown, and potentially fires. Derating is the process of reducing the allowable ampacity of a conductor to compensate for factors that reduce its ability to dissipate heat. These factors include bundling, high ambient temperatures, and enclosed spaces. The NEC requires derating in these situations to prevent overheating and ensure the safe operation of electrical systems. MC cable is a type of cable that consists of one or more insulated conductors enclosed in a metallic sheath. The metallic sheath provides mechanical protection and serves as a grounding conductor. NC cable is commonly used for power, lighting, and control circuits in commercial, industrial, and residential buildings. Current-carrying conductors are conductors that carry electrical current under normal operating conditions. These include phase conductors and the neutral conductor in some systems. Grounding conductors are not considered current-carrying conductors because they only carry current during a fault condition. The neutral conductor in a three-phase, four-wire system may carry significant current if the loads are unbalanced or if there are nonlinear loads present. Nonlinear loads, such as electronic equipment, can generate harmonic currents that flow in the neutral conductor. These harmonic currents can increase the temperature of the neutral conductor and require it to be counted as a current-carrying conductor for derating purposes. Ambient temperature is the temperature of the air surrounding the conductors. The ampacity values in the NEC tables are based on a specific ambient temperature, typically 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher, the allowable ampacity must be further reduced to prevent overheating. Enclosed spaces are spaces that restrict air circulation and prevent heat from dissipating effectively. Examples of enclosed spaces include conduits, cable trays, and insulated walls. When conductors are installed in enclosed spaces, their ampacity must be derated to compensate for the reduced heat dissipation. Cable ties are used to bundle and support cables. When using cable ties, it is important to avoid over-tightening them, as this can damage the insulation and reduce the cable's ability to dissipate heat. Cable supports are used to support cables and prevent them from sagging or rubbing against other objects. Cable support should be spaced according to the manufacturer's instructions and the requirements of the NEC. Harmonics are electrical currents or voltages that are integer multiples of the fundamental frequency of the power system, which is typically 60 Hz. Harmonics can be generated by nonlinear loads such as electronic equipment and can cause a variety of problems in electrical systems, including overheating, voltage distortion, and equipment malfunction. Insulation is the material that surrounds the conductors and prevents them from coming into contact with each other or with a metallic sheath. The insulation must be able to withstand the voltage and temperature of the circuit and must be resistant to moisture, chemicals, and other environmental factors. A short circuit is an abnormal condition in an electrical circuit in which current flows through an unintended path with very low resistance. Short circuits can cause a large amount of current to flow, which can lead to overheating, insulation breakdown, and potentially fires. A ground fault is an abnormal condition in an electrical circuit in which current flows from a conductor to ground through an unintended path. Ground faults can cause electrical shock and can also lead to overheating and fires. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a predetermined level. Ground fault circuit interrupters, or GFCIs, are used to protect people from electrical shock. These devices are designed to detect ground faults and interrupt the flow of current very quickly. The electrical codes are sets of rules and regulations that govern the design, installation, and maintenance of electrical systems. The NEC is the most widely used electrical code in the United States. Local codes may also be in effect and must be followed. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical installations comply with the applicable codes and standards. Electrical permits are required for many types of electrical work. These permits allow the local authorities to track electrical installations and ensure that they are inspected. Qualified electricians are licensed and trained professionals who are qualified to perform electrical work. They have the knowledge and skills necessary to design, install, and maintain electrical systems safely and effectively. Electrical safety is of paramount importance. Always follow safe work practices and use appropriate personal protective equipment when working with electricity. Never work on live electrical circuits unless you are properly trained and equipped. If you are not qualified to perform electrical work, hire a qualified electrician. By understanding the Derating requirements for bundled MC cable and following safe work practices, you can help to ensure the safe and reliable operation of electrical systems. When calculating the Derating for multiple cables in a bundle, it's important to consider all current carrying conductors, including those in different cables within the bundle. For example, if you have two MC cables, one with 3 current carrying conductors and another with 2, you would need to derate based on a total of 5 current carrying conductors. The NEC provides specific guidelines on how to determine the number of current carrying conductors in a cable or raceway. Refer to the NEC for detailed information. In some cases, it may be necessary to use a larger conduit or cable tray to accommodate the bundled cables and provide adequate space for heat dissipation. The size of the conduit or cable tray should be determined based on the number and size of the cables as well as the fill requirements of the NEC. When installing MC cable in a cable tray, be sure to support the cables properly to prevent them from sagging or rubbing against the tray. Use cable ties or other supports to secure the cables to the tray at regular intervals. The NEC specifies the minimum bending radius for MC cable. Avoid bending the cable too sharply, as this can damage the conductors and insulation. Refer to the NEC and the cable manufacturer's instructions for the correct bending radius. When terminating MC cable, use the proper connectors and fittings. Ensure that the connectors are properly tightened and that the conductors are securely connected. Loose connections can cause overheating and electrical hazards. The metallic sheath of MC cable must be properly grounded to provide a path for fault current. Use grounding connectors and bonding jumpers to connect the sheath to the grounding system. The grounding system must comply with the requirements of the NEC. When installing MC cable in wet locations, use cable that is rated for wet locations. The cable should be marked with the letters wet. Use waterproof connectors and fittings to prevent moisture from entering the cable. When installing MC cable in hazardous locations, use cable that is rated for hazardous locations. The cable should be marked with the appropriate hazardous location marking. Follow the requirements of the NEC for installing cable in hazardous locations. When working with MC cable, always wear appropriate personal protective equipment, including safety glasses, gloves, and a hard hat. Avoid working in damp or wet conditions. Be aware of the potential hazards of working with electricity and take precautions to prevent accidents. If you are not sure how to perform a task safely, ask for help from a qualified electrician. Regularly inspect MC cable installations for signs of damage or deterioration. Look for cracks, cuts, abrasions, and corrosion. Replace any damaged cable immediately. Keep MC cable installations clean and free of debris. Dust, dirt, and other contaminants can reduce the cable's ability to dissipate heat. When troubleshooting electrical problems, start by checking the MC cable connection. Loose or corroded connections are a common cause of electrical problems. Use a multimeter to check the voltage and current in the MC cable circuit. This can help you to identify the source of the problem. If you are not able to troubleshoot the problem yourself, call a qualified electrician. Always disconnect the power before working on any electrical circuit. Use a voltage tester to verify that the power is off. Follow lockout/tagout procedures to prevent the power from being accidentally turned on. Be aware of the potential for arc flash when working with electrical equipment. Arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. Wear appropriate arc flash protective clothing when working on energized equipment. Never work alone when working with electricity. Have someone nearby who can help in case of an emergency. Know the location of the nearest electrical panel and how to turn off the power in case of an emergency. Have a fire extinguisher nearby in case of an electrical fire. Regularly review and update your knowledge of electrical safety practices. Attend training courses and read industry publications to stay up to date on the latest safety information. By following these safety tips, you can help to prevent electrical accidents and injuries. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always use caution and follow safe work practices.